Hello friends, welcome to another video, and today we're going to see the problem which is asked in your examination in May 2011, that find the current I using source transformation, and the circuit is given below here. So this is my circuit, and I want to find this current I over here, okay, through this branch, hmm, by using source transformation technique. So what is source transformation technique? The simple meaning of source transformation means transform of one energy source to another energy source. Okay, so let's check this circuit. We have a current energy source, okay, and a voltage, that is another energy source. So the transformation of source means to convert a current energy source into a voltage energy source, or convert a voltage energy source into a current energy source. So this is the transformation of circuit means. Okay, so to get a brief idea of how we convert our current energy source in a voltage and a voltage in a current, let's see this. So the source transformation depends upon the position of resistance with a current and voltage source. Remember this, the position of resistance is very important in a source transformation. Okay, so check out this circuit given below, which explain the current to voltage conversion. Okay, so the current source can be converted into a voltage source only if the resistance is in parallel to it. So resistance must be in parallel, that is, see over here the circuit, that the current source is here and the resistance is here, and these two things are parallel to each other. Okay, so the resistance must parallel to the current source to convert it current source into a voltage source. And how you will convert the current source in a voltage source? By using Ohm's law, that the voltage is just given by I into R. Okay, so by finding the value of V, I will convert my current source in a voltage source. And remember this, here the current source is in parallel with the resistance, but after conversion my voltage source must be in series with the resistance. Okay, so this is my voltage source, and you can see my voltage source is in series with the resistance. Okay, so this is how the current sources get converted into a voltage source. Let's check how the voltage source get converted into a current source. Okay, so this is the circuit of converting a voltage source into a current source, and the voltage source can convert it into a current source only if the resistance is in series with the voltage source. To convert the voltage source in a current source, the resistance must be in series with the given voltage source. And after conversion, how our circuit look like is shown in this figure. You can see the current source value, which can easily found by using your voltage, that is V upon R. Okay, and the current source must be in parallel with your resistance. Okay, here the voltage source in series with the resistance, but after conversion the current source is in parallel with your resistance. Okay, so this is what a source transformation is. Now let's go to our problem again. Now here's our problem, and we need to find the current through 3 ohm resistance. Okay, so to find the current through 3 ohm resistance, remember the current the branch current which is asked to find, uh, the branch should not be eliminated. Okay, the branch should be there. That is, if I ask to find the current from 3 ohm resistance, so my this branch should be there in a circuit, and I will try to merge this resistance of 2 ohm and 6 ohms in one resistance, so I can calculate my current through 3 ohm resistance. The second thing, I need to use a source transformation technique. Okay, so let's discuss this little bit. We have a voltage source which is in series with 2 ohm resistance, and the current source which is in parallel with 6 ohm resistance. So should I use current to voltage source conversion, or a voltage or a voltage to current source conversion. So let's read our problem again. We asked to find a current, so I will convert my voltage source in a current source, uh, in a current source, uh, because it would be easy to find the current, overall current in a branch. So knowing this, let's start our problem. So converting a voltage source of 10 volt into a current source. Okay, so this is my branch over here, you can see, and the voltage source of 10 volt is in series with a 2 ohm resistance, and I have to convert this into a current source. Okay, so my from Ohm's law, excuse me for this, uh, we need not to write every time the Ohm's law. Just by using the Ohm's law, that is I equals to V upon R. So what is the value of V? V is 10 volt, that is given to us over here, and the R is 2 ohms, okay, which is the only resistance in series with the uh, voltage source. So V upon I will give me 5 ampere. So my current, the current source must be of 5 ampere. And how will I will put my current source in a circuit that is in parallel? You can see over here, I placed my current source of 5 ohm in parallel with 2 ohm resistance. Okay, so this is the source conversion. So and now we will also we will see that how our circuit is going to look after this source conversion. uh, so combining, you can see over here, my 5 ampere, my 5 ampere of current source is in parallel with 2 ampere, and my 3 ampere of current source is parallel with 6 ampere. Now the only thing I need to do is to combine this 6 ohm resistance with this 2 ohm resistance. Okay, so I will use my parallel combination, that is 6 ohm resistance is parallel with 2 ohms resistance, which will give me 1.5 ohms of resistance. And this over, you can see in a diagram that I combine this 6 ohm with a 2 ohm resistance. Okay, similarly at the same point I will also combine my 3 ampere current source with a 5 ampere current source, as both the current source showing in going in this direction, that is they are in same direction. Okay, so the combining current source, the combining the current source value get added. Okay, so adding total I T, that is total current in a circuit, is just 3 ampere plus 5 ampere, which gives me total current, that is 8 ampere. So after doing this combination, uh, my circuit will look like this. Okay, you can see over here, that is my 8 ampere current source, that is total current source, which I calculated previously over here, and my 1.5 ohm resistance, which I found by just combining 6 ohms and 2 ohm resistance over here. And my 3 ohm resistance is just to remain same. I not I just, I just not touch that 3 ohm resistance, because it is important to find the current through 3 ohm resistance. Okay, so it is now just it by looking the circuit, I can guess that it is just a current divider rule. It is just to find a current in a two branch, and I will use my current divider rule over here. And what current divider rule says, that the current in your to find the current in your desired branch, you need to multiply by total current. Okay, so the total current is of 8 ampere, so I will multiply my total current into opposite resistance. What is opposite resistance? So this is my desired, so this is my branch, and from this branch I need to find the current. So my opposite resistance is 1.5, because this is my desired branch. So my opposite resistance is 1.5. So 1.5 upon sum of two resistance. Okay, the sum of two resistance, that is 1.5 plus 3, 1.5 plus 3, and the resultant value I get, that is, by doing this calculation, you will get your current value. Okay, you will get your current value from 3 ohm resistance, that is 2.67 amperes. So this is my current value which is I require, which I asked to find. Okay, so this is my current value, this is my current value, which is 2.67. Thank you.